Let us solve the equation a plus 2ab plus b equal to 8 in integer. So we write this equation once again. Let's call it to be equation 1. You may expect that you will get a large number of solutions because a and b are independent of each other, but that is not true. You will get a few number of solutions. Now when we say integer, with that comes something that comes to our mind is definitely factorization. Any non-zero integer can be factorized uniquely. Now, do we have factorization here? What we can say is that we can take a common from this expression. Let's do it. If I take a common, then I am left out with 1 plus 2b plus b we copy as it is equal to 8 we copy as it is. Now, still we are not able to factorize the left hand side, but you see that we have 2b here and just b here. So let's multiply this equation, say equation 2, by 2 throughout. Okay, we are simply multiplying this equation by 2 to get 2a, 2b, and 2 into 8. You can see that we have nice numbers like 2a, 2b, and 2b only. But still we are not able to factorize. You can see that 1 plus 2b here, but just 2b here. What can we do? If we add 1 to both sides, then maybe we can factorize it. So we are just adding 1 on both sides. 16 plus 1 is 17 of prime. Oh, nice. We will have very few factor of prime. Further, we observe that we have expression 1 plus 2b and also 1 plus 2b. So let's take 1 plus 2b common and factorize the left hand side. Once we take 1 plus 2b common, we are left out with 2a plus 1 equal to 17. Now we see this is an integer. 1 plus 2b, that's an integer. 1 plus 2a is also an integer. Their product is exactly equal to 17. So we have limited choices of 1 plus 2a and 1 plus 2b. They are definitely factors of 17, and factors of 17 are, we need to say integer factors, plus minus 1 and plus minus 17 only. So let's write in the form of table 1 plus 2a. We have limited number of choices. It is either 1 or minus 1 or 17 or minus 17. That's the only integer factor of 17. What about 1 plus 2b? If 1 plus 2a equal to 1, 1 plus 2b has to be equal to 17 because product is 17. Similarly, if 1 plus 2a equal to minus 1, 1 plus 2b has to be equal to minus 17. If it is 17, 1 minus 1. Now, from there, definitely we can determine the value of a and b. If 1 plus 2a equal to 1, then a has to be equal to 0. If 1 plus 2b equal to 17, then 2b has to be equal to 16, so b has to be equal to 8. Once again, if 1 plus 2a equal to minus 1, then 2a has to be equal to minus 2. So a has to be equal to minus 1. 1 plus 2b equal to minus 17, then 2b has to be equal to minus 18. So b has to be equal to minus 9. What about if 1 plus 2a equal to 17, then of course they will just reverse. We are just interchanging. So 8, 0, minus 9, minus 1. So the solution are given by a comma b equal to 0 comma 8 comma 8 comma 0 minus 1 comma minus 9 and minus 9 comma minus 1. These are the only possible for choices of integers a and b.